All right, John, it's all yours. And you know how to run the Mac, so it's all yours. Let's get more attention. You guys get come get more. Yeah, like one slice. Somebody took one slice. I can't eat all this. All right.
So with the help of, and a few others, Cisco, Apple, Protocols.com, and some of my great friends at Wikipedia, I'm going to be talking about AppleTalk and Macintosh networking. It says 101, but this is really, really basic, just because AppleTalk is actually not, quote-unquote, really a current standard, although it is still in effect, and I'll explain that to you guys here in a minute. What is AppleTalk? AppleTalk is a suite of network protocols developed by Apple Computers Incorporated for file and print sharing in Macintosh-based networks. It was designed as a LAN system for the first Macintosh personal computers released in 1985. It was relatively inexpensive compared to other systems in use at the time, and other systems in use at the time were like Ethernet, and Token Ring was around at the time. And it was actually an early implementation of a distributed client-server networking system. To expand on that, a computer would act as a server. So say I had a printer on my Mac, and one of you guys wanted to use it. Well, your computer would actually be the client. My computer would be the server because your computer would be wanting something from me. So, and AppleTalk was actually built into all of the earlier Macs so that they can talk to each other and actually share files and printers and so forth and so on. It was built to support Ethernet and the Token Ring system. It was built to act in conjunction with them at a time when a lot of protocols were actually out, and a lot of different systems for setting up LAN networks were actually being set up. A little bit more about AppleTalk. Again, it was built to support IBM's Token Ring. That was Steve Jobs and Apple's basic system they were planning to support was the Token Ring, although there were other systems out. Ethernet eventually overtook Token Ring and wasn't actually out long before it did, but they did build the system to support the Token Ring system, which actually was came out late in 1984. It was built into all the early Macs and into laser printers. So Apple actually developed this big hunking machine called a laser writer, really early laser printer, and you plug the printer into your Mac and nothing else, just go for it. It was actually the start of the plug-and-play systems that we have now. You plug in your printer and your computer automatically recognizes it, automatically gets the drivers from it, and you just go for it. It was also made available for IBM PCs, since they were the big maker at the time, and their clones, since everybody was like, I want to be like IBM, although not so sure that's the thinking nowadays, but hey. The AppleTalk system allowed a speed of 230.4 kilobits per second, maximum distance of 1,000 feet. So that was the maximum distance of the network. So pretty much this room, you had your network in. And only 32 nodes per LAN. It did allow for future expansion for up to 255 nodes, although at the time it was released, you weren't capable of doing 255 nodes, but it did max out at 255. It was slower than a few of the others that were out at the time. TCP/IP was also out at the time, and making waves, but it wasn't really big at that time. Using a bridge, and in case anyone of these wondering what a bridge is, it's essentially what we think of as a router, only it's slightly different. But you could use a bridge to connect one line to the next. So I could have my own, then you can have your own, and we could actually put a bridge in the middle and make a bigger network. How it worked. Really bare bones. Again, this is really basic. Plug and play addressing, no configuration. So what that means is with TCP/IP, you have to do some configuration. You got to type in some stuff. You got to, stir the pot. With AppleTalk, I plug my Mac into yours. It would automatically recognize it, and we could share files just like that. There was no you had to pick an address. It automatically gave your computer an address. So you didn't have to do any work. You just plugged it in and went for, whatever you needed. It was connected to the computers via an adapter to the serial port. So you plug in a cable into the serial port, and there's this adapter that has 2 other serial ports on it. Other adapters were made by third-party companies that came out later. One of the ones was a telephone one that actually used the standard telephone cable because a lot of people had telephones and had telephone cables, so it just made sense. I couldn't find a really good picture of one, and I didn't feel like, honestly, blowing one up and resampling it. But if you know what the you ever had DSL, the little phone things your phone company gives you to put on your phone line so there's no interruption? That's exactly what the telephone adapters looked like. And pretty much the AppleTalk adapter looked the same, only it was a single grounded cable that plugged into your serial port instead of a telephone cable. You didn't need to have hubs or wires connected in a loop. So like with the token ring system, all of the computers are networked together and they're all looped together, so they all had to be connected at one point. With the AppleTalk, if I plugged in my computer, but like the guy next to me didn't want to be on, I didn't have to terminate my cable anywhere. I just left it unplugged. Somebody could jack in later on and connect to the system and just go from there, and there was nothing else they needed to do with that. The AppleTalk system has 11 protocols. I'm not really going to go into detail on what each one does because you'll never remember. It's a short presentation and you won't remember what each one does. The reason I bring up the protocols is to show how they actually interact on the OSI model. One of the protocols, the AFP protocol, actually takes up 2 layers on there. If you look at the bottom, you'll see in the data link layer there's a snap and an LLC. Those aren't actually protocols from AppleTalk. That's actually where the different systems that Apple came up with, like EtherTalk and TokenTalk, which was just how they connected to the different systems like Ethernet and the token ring system. That's where they hung out on the OSI model. I actually pulled this picture off of protocols.com. I'm not sure what the snap and the LLC is. They didn't really explain it, but something else actually goes in that place. So what came next? Because as I mentioned, AppleTalk isn't a current standard. Due to the rapid expansion and acceptance of TCP/IP in the 90s, Apple began adapting the protocols of TCP/IP. They couldn't get rid of AppleTalk because they had already made computers, and a lot of universities were actually still using the earlier Macintoshes with the AppleTalk system. AppleTalk was officially discontinued with the release of OS 10 10.6, which is Snow Leopard. Bonjour is actually the next implementation of AppleTalk. Apple created it. It's actually open source. You can actually download it for PCs at your leisure. It's built into a lot of actual laser printers nowadays. It has the same principles as AppleTalk, only it incorporates a lot more of the TCP/IP into it, but it still allows for a wide range of plug and play, especially between Macs. So if you take one of your new Macs now and plug it into, say, my Mac, you could actually link into my Mac as long as my sharing is already turned on without having to do anything else. If I didn't have a password, then you have free access to my computer. If I have a password, you of course have to know that to gain access to it, but other than that, you have free reign of my computer. All Macs still have Apple Talk in them in the form of Bonjour. All new Macs are still plug and play. Like I just explained, you can plug your Mac into mine and go for broke. And all new Macs support the TCP/IP protocols as a standard. Any questions?
So I know there's iMessages on the new. I mean,
Yes.
Yeah. I was just wondering because just when you said Bonjour, you know the default name you guys Bonjour. You don't type it. I was just wondering if that's because they use this.
The iMessages is actually a cloud-based service linked into your Apple ID and the Apple Store. So, for instance, I have a Mac in every room in my house, and I have an iPad in 3 of the rooms in my house. If I don't specify anything when I set up iMessages, the messages will go to every single system that I have. It's kind of like iPhoto. If you put a photo into iPhoto and you don't turn off the iCloud sharing, like right now, every photo that we have from the photography business is actually on my cell phone because it's shared through the cloud, and that's the same type of system that the iMessages use.
Good presentation, excellent presentation. As far as Bonjour, as far as future growth or anything you can see in your research, or some things you maybe stumbled across when you were researching on Bonjour?
I didn't stumble across a lot on Bonjour. I didn't actually delve into it extensively. They are still developing it, and since it is open source, the development has actually took off a lot further since Apple actually developed the system and changed it over. But I do know that it is the protocols themselves are standard in all network printers, so they all have them.
Is Bluetooth the same thing, or does it do the same thing, or is it?
No, they're two completely different things. Bluetooth uses radio waves. With the Apple Talk and like the Bonjour, you actually have to be a part of the network. It's a protocol for network addressing, like TCP/IP. The only difference is it automatically configures the address for you. You don't have to go into any router settings or address your friend's computer before you go ahead and set up a network with them. You plug it in and you go. Yes, sir?
More of a comment than a question, but it's funny to bring up Bonjour. The little app I showed off earlier, I'm currently trying to find a way to implement Bonjour into it. So you don't have to type in your partner's IPs. It would search the network and populate a list of other people using that app.
There you go.
So that's just...
there is actually a, since you mentioned future development and you mentioned implementing it into your app, there is a, I don't know the actual term, but with Bonjour, there's, because everybody's developing on it, there is a development of it that actually allows it to implement that same way into different systems. If you go to, it's on the Bonjour development website. There's a link to it. It tells you the guy who made it and what he's doing with it.
Let's give him a hand. Good job. Excellent. All right, as always, for the next, as the next presenter is coming up, let's fill some place up with some food. Thank you. Appreciate it. Got chips, you got pop, you got. Thank you, Jack. Okay.
It was 19.
I have up here. Okay. Aha, that's you. PDF, right?
Yeah.
There you go. That looks good, right? And then you can advance the thing yourself, and don't push that button, and you can put that in your wire. That'd be awesome.
Have you heard of AirDrop? Yes.
Wait for everybody to sit down and start.
Is it right here?
Yep.
Airdrop
Advance.
is like
That way. Yep. There we go.
the, I don't know what Microsoft calls it now.
That's all there is.
SkyDrive.
One sheet.
They changed the name. Microsoft Live Drive, that changed to SkyDrive, is now OneDrive.
Everybody got some stuff, right?
Xbox One.
Y'all ready? All right, let's go for it.
All right. I picked the topic of malicious code because I personally had a bad experience with that about 9 months ago. My computer got a virus. And once I got that virus and was checking out how to get rid of it, and it cost me $200 to get rid of that virus, I started getting interested into this computer IT security and what it's all about. That's why I'm here today. So, it is estimated that cybercrime victims and internationally loses $750 billion yearly. And it's estimated that more than 150,000 computer viruses are in circulation every day. And 148,000 computers infected daily. So that's a lot of computers, a lot of viruses that are out there. And one of the ways to stay safe is if you don't lock your car, you know your car is vulnerable to be broken into, in the same way with your computer. If you don't keep your computer safe, it's going to get hacked into. Malicious code. It's also known as malware. It is software used to disrupt your computer's operation, steal sensitive information, or gain entry into your computer. Malware can appear in the form of code, scripts, active content, and other software. Malware is different than faulty software, which is an authentic software that includes destructive bugs that were not corrected before their release. Generally, most systems include bugs or loopholes which may be manipulated by malware. A classic illustration is a buffer overrun vulnerability in which an interface intended to store data in a small part of memory permits the caller to provide more data than will fit. This additional data then overwrites the interface's own executable structure. The malware can then override the system to perform malicious code by substituting valid code with its own code of commands copied into the live memory outside the buffered area. This is malware. Includes computer viruses, ransomware, worms, Trojan horse, rootkits, keyloggers, spyware, adware, and rogue security software. The definition of a virus is a code segment which reproduces itself by assigning exact copies to accessible executables. And there is necessary characteristic of a virus is replication, requires a host, program as its carrier, activated by an external action, and replication is limited to virtual systems. Viruses and worms are associated with malicious code and often thought of as the same type of infectious bug. They do share one essential objective of replication. However, there is a distinct difference to how they use their host system. Viruses usually attack personal computers, while worms are more likely to infect multi-user systems. A computer that has been infected by a virus has been transformed into a Trojan horse. That is, you expect the program to perform a useful function, but has been programmed to run a viral code. And it also executes the task of duplication. For a malicious program to achieve its end result, it must be able to run without being identified, shut down, or deleted. A familiar way that spyware could be circulated is as a Trojan bundled with software you download from the internet. As of 2012, roughly 60 to 70% of all active malware exploited some kind of click fraud to fund their activity. A little bit of history of viruses. Before the huge explosion of the internet, viruses spread on personal computers by corrupting the executable boot sectors of floppy disks. By implementing a copy of itself into the computer code instructions in these executables, a virus would cause itself to be ran whenever a program was run or the disk was booted. Executable infecting viruses are reliant on users trading software or bootable floppies or thumb drives. Viruses would spread fast in computer hobbyist groups in the earlier days. The first worms did not originate on personal computers, but on multitasking Unix systems. One of the first well-known worms was the Internet worm of 1988. That particular worm infected Sun OS and VAX BSD systems. This worm didn't attach itself into other programs. Instead, it utilized security weaknesses in the network server programs and began running as a separate process. This is the same process used by worms today. Today, with Microsoft Windows and flexible macros of its application, it has become feasible to insert malicious code into the macro language of Microsoft Word and similar programs. These micro viruses corrupt documents and templates rather than application, but need to rely on the fact that the macros in the Word document are a form of executable code. So how can anti-malware protect you? They can afford real-time security against the installation of malware software on the computer. This type of malware protection functions the same way as that of an antivirus protection in the anti-malware software. Examines all received network data for malware and blocks any threats it comes across. Another way is that anti-malware software can be used exclusively for the detection and removal of malware software that has previously been installed onto a computer. This kind of anti-malware software looks at the contents of the Windows registry, operating system files, and installed programs on a computer, and will provide a list of any threats found, allowing the user to choose which files to delete or keep, or to compare this list to a known list of malware components and removing all the files that match. Some important steps to protecting your computer. Keep your firewall on. The firewall helps protect your computer from hackers who might try and steal confidential information, passwords, or even try to crash it. Install or update your antivirus software. Antivirus software is intended to avert malicious software programs from embedding on your computer. Viruses are able to infect your computer without you even knowing it. Update your anti-spyware technology. Some spyware collects information about you without your permission or produces unwanted pop-up ads on your web browser. Be very cautious about the ads on the internet proposing downloadable anti-spyware. In some instances, these products are spyware themselves. Make sure your operating system is up to date. Computer operating systems are continually updated to stay in tune with technology requirements and also to remedy security vulnerabilities. Make sure your computer has the current updates to ensure that you have the up-to-date protection. Be careful what you download. Never open an email attachment from someone you don't know or forwarded attachments from people you do know. They may have unknowingly infected your computer with malicious code. Turn off your computer. Many computer users choose to leave their computers on, and the downside to that is if it's always on, it leaves your computer to be more susceptible or whatever. And in closing, I'd like to remind everyone that your computer is only as safe as you make it. Follow the security measures that we have learned here in PCT110. A few steps of precaution will help in warding off potential hackers, and don't get hacked because of careless downloading software from the internet.
Just have a comment. I was just wondering
Sure.
about the other guys. When you download free antivirus software, I would never do this, but I mean it's free. But if you download it, you know how sometimes it comes with a trial date of 1 month, 2 months, 3 months. I noticed after that period, if you uninstall it and then you download it again, it'll restart again. Yeah. So, yeah.
I know. I think that's what happened to mine. I downloaded something, and after I had downloaded this particular thing, it was like a toolbar or something. and they packaged in a bunch of stuff with it. And after that, here it comes, all those ads popping up. Yeah.
After you had it fixed, did they tell you what type of code infected your computer, whether it was malware, spyware, virus?
No, they didn't, but they were speaking an Indian language, so I'm sure they were far away. But it was that's another reason that I really was getting into this, is because as they were going through my computer, I was sitting there watching them go through my computer. They logged onto mine, and
That's good. If you would have called, that's why they would totally find your laptop.
and they actually showed me that where it had gone in, turned off my security settings, and I'm like, wow, you know, they really get in there and mess with it.
As far as what do you use for your antivirus at home? What brand do you use?
Mine is, man, it runs every day. I can't remember what the name of it. Is it Super Spyware?
Super Anti-Spyware?
What's that?
Super Anti-Spyware?
Something like that. Yeah, it's got a little guy with dark glasses now, you know, kind of. No, it's not too that well. Yeah, you know what? I just I should probably know, but I don't
No,
know.
that's fine.
I'm paid up for a year, so.
You're fine. Let's give him a hand. Good job.
Thank you.
You did this thing?
Yeah. Okay, while the last presenter is preparing to come up, one last poll for pizza, and then after this last presenter is done, we are finished for the semester. I was going to give a tour in the IT lab, but they've got some stuff going on over there, so I'm not going to do that. But definitely, I've enjoyed you guys as a teacher. Hopefully, you learned some stuff in networking this semester. And did you all say it?
Just to throw it out there, Mac users, you're not always that safe. Macs get viruses too.
Oh.
Yeah, they do.
Yeah, and when they do, they're bad. Macs don't get viruses as often as Windows computers do, but Macs never get small viruses. They get from a guy who has a flash drive that most Macs have.
This is yours, right?
Yep.
Okay.
Is that because of a lot of
Super
viruses they attack, or
Oh, I like that. I'm good.
Yeah, well,
Windows
Because
Yeah.
Windows is more mainstream.
Windows
Oh,
users
there you
also
go.
got a more
Alright.
open dev kit. Apple is very,
If you want
very
to sit down, you can.
source, so you can make a virus for an Apple-based computer.
Okay, let's give our attention. This gentleman
than a
is
Windows computer.
Mike says present.
So to change
All
the
yours,
slides,
sir.
is it up, down, or left, right?
Yeah, the bottom right keys, the arrow keys, yeah, go right to advance, back to come back.
Okay.
Alright.
Well, this semester I enrolled as a student in the Cisco routing and switching program here at Rock Valley. Through that, I learned a lot of information. I came in here knowing nothing, and now I'm sitting here coding routers. So it's a very awesome program we have here. So what I'm going to present on tonight is the OSPF routing protocol. Okay. No, spacebar, left, right, up.
Oh, no, nothing?
And I'm not a Mac proficient.
I didn't set it up. I did not set it up right, I bet. It helps to set it up right. Okay, that's why it has to be individual window. I didn't do that. And let's go full screen here. Voila.
Alright, so a little bit about OSPF. Stands for Open Shortest Path First. It is an open source routing protocol, and first thing that we would have to really decide is what a routing protocol is. It is formally used by routers to determine the appropriate path on which data should be forwarded. The way it does this, OSPF, is it calculates basically the bandwidth that a specific line has. Like it calculates. I can't turn this there, but let's just do a little bit more background, and then I'll go back. OSPF is the result of multiple research projects. There's actually three, I thought it was four. But 1978, way back, well before the internet was even around. Like these guys are really getting into it. It's based on the Dijkstra algorithm, named after Edgar Dijkstra. Wasn't even for computers. Guy was just a mathematics guy. He would set up these little, it's kind of like, I wish I had a drawing of it, but it'd be like an octagon or whatever. He would assign random numbers to the octagon, and they connect them in different paths. And basically, all it was trying to figure out which one of those paths would be the quickest way to get to the other end, whichever end you're trying to go to. This last page here really just has all the different terms it relates to OSPF. There's two different main types of routing protocols. There's IGPs, which is an internal gateway protocol, which is what OSPF is. There's also EGPs. As far as I know, there's only one of those that I've even covered, which is the border gateway protocol. Within those two subcategories, there's link state protocols, which is what OSPF is, and what link state protocols do is instead of broadcasting constantly over the wire, like, hey, these are all the networks I'm connected to, and broadcasting that to other routers to kind of keep like a coherent network so that they know where everything is. Link state only sends those updates every 30 seconds, or if something happens, like say there's a power outage at this building, so then we'll send out, hey, this network's no longer available, and then everybody else takes off their routing tables. So what link state does is instead of being distance vector, which is what the other type is, distance vector sends out those things every 30 seconds to everybody, regardless of what happens. That sends out all this overhead on the network. So link state reduces all that overhead down to a bare minimum. So, as I was talking about earlier, it goes based off of bandwidth as its cost, how it determines where to send packets, determines the best, shortest path first. So, now, when you first turn it on, it goes through these 7 stages here, from down, and then those are like actual names that they're called. The first state is down. That is literally, you just turn it on, it's going through its local process. The init or initialization state is, after it gets through that, it sends out these things called hello packets. It sends it out on every single line that it's connected. This is my router, this is all the networks I'm connected to, is there anybody out there? The two-way state after that is when another router does another hello packet. So they start communicating, and that's the exchange start stage. And then there's the exchange stage, which really they should just be basically the same thing. Somebody had an idea to split it up into 2 stages. After that, it goes into the loading stage, and that's when it's doing the calculation based on all the bandwidths of the wires that it's connected to, so that it can learn really the exact picture of what's going on. While it's doing the loading, it's going through that Dijkstra algorithm, literally drawing out the physical network, and all of the routers that are on the network come to the same conclusion. When they all come to the same conclusion, they're set to go to full convergence stage. Part of coming to that full stage, you have to program in something for the election. Yes, there is an election. They're electing the designated router or the backup designated router. Designated router keeps track of like all the routes available. It's kind of like the main database. You want it to be like the easiest router that you got. And the backup, obviously, is just for that redundancy. The way that it's elected is first you have to program in router ID. and it goes off of whatever's highest in all these states, whatever the highest one that you want it to be. So it can be anything from like 1.1.1.1 to 255. Whatever that. Now, if you didn't program router idea, because you can just skip that, it would go next to your loop packet address, which again, you have to actually program that into some routers. And whatever the highest one after that would be the designated router. And if you didn't program that, then we go to IP address. The thing that got me interested in even presenting a little bit on the OSPF protocol was this election process. It's kind of like, it sends out these messages that goes, hello, I am your master, you are my slave, to these other routers, and it's just kind of comical. So with the election, you can kind of rig it. Another thing that's a little bit of a joke to me, because it's kind of like, you live in Illinois, rig elections, vote as much as you want. But that's really all I can think of. But that's one of the biggest things with Cisco, and I just wanted to really keep it on the back of my mind. So
That's not twofold. Like when I buy my router from Best Buy,
Yes.
it's at home.
Yes.
I don't program it. I don't do anything. It runs. But here on the routers, we have like Cisco 2, right? Where you don't have to program it.
Yep.
Now, why? First of all, why is it different than the one I buy at Best Buy, where it does everything for me? And second, why would you want to program it if my Best Buy router does everything for me?
Well, the ones that you buy for your house, as far as I know, it kind of just comes pre-programmed. Somebody had to do it. They wrote a program to load it onto the this hard drive of the router that you buy. When you get into like IP networking like this, with big, huge campuses, whatever, if you were to do that, I think you'd be having a lot of problems. First, you have to like statically assign every single computer, and then what happens if one changes? Then you have to go back in and re-statically assign IP addresses to every single computer. It would be an absolute nightmare. But I was thinking that too, because I just actually got a new router in my house, and I was looking around. Kind of fun to know what all those things mean, though, like when you go into the advanced settings.
Good presentation. Wanted to, as far as future, I know it's open source and things of that nature. Future development or future, I guess my question is, besides Cisco, is there any other companies utilizing this open source?
In my research, everything I was coming across was saying because it's open source, it's widely used. It's one of the most widely used networking protocols because of that fact. It's it's free. It's out there. It takes out that cost. As far as future, basically all I did here was OSPF version 2. That's IPv4. There's also OSPF version 3, which is for IPv6. So.
Good presentation. Let's give a hand. All right. Well, with that, you guys have been an awesome class. Final grades will be emailed to everybody by next Tuesday. And next week, though, is the official finals week for campus. You will not come back here next week. This was your final, the presentation and paper. Before you leave, if you could take all your stuff with you that you brought, that'd be awesome. If you want more pizza, that's great. I can eat one or maybe one more slice. That's about it. But you guys have been a great class. Hope you learned some things. I know I'm having some in the summer. I'll see you in summer session 2. See some in the fall. If you have any questions about any classes I'm teaching or going to be teaching, definitely shoot me an email. I have on my website now, my cconco.com, a text message. You can text me or call me. But it's not my real number. It's actually Google Voice, so it's not my real number I'm giving out. But it is kind of cool that I put it out there today just to think for students of registration. I'm thinking, nobody else is going to use it for a while. As I hadn't been out there like an hour and a half, and I got a voice message, and I wasn't available at the time, so Google answered the voice message. And what was cool about it was on Google Voice, it'll transcribe the message for you to where you can see the message, before you listen to it. And granted, it doesn't give all the words right and stuff sometimes, but it was kind of cool to be able to see that immediately. And then the student, I called back and had to fill out the prereq waiver for. But I definitely recommend Google Voice. I've set it up for a number of faculty here, and you can get it for totally no cost. And when you get a Google Voice number, you can give that to anybody, and they can call that number, and you can have it come to your actual real phone, or you can have it just go to email. And when they put that voicemail in there, they'll transcribe it. Google will transcribe it, and then text you when it's done. And it's awesome. And you can use it for job interviews. You can use it for giving out numbers on whatever, to where you don't have to worry about coming back to your real number. Because we all get tired of marketing numbers, marketing calls, and so that helps tremendously. Because Google has its own database of marketing robocalls and stuff, and they block all that stuff, so you don't have to worry about it. So definitely recommend Google Voice. I was pretty impressed with that. I've set it up for a lot of people, but this is the first time I've ever personally used it myself, and been pretty impressed with it. So, guys, been a great class. Hope to see you next fall and summer. Come by and see me if you're not having me for any of the classes, and see you around. Have a good summer. And I got ended your session, so you're good to go. All you need to do, you don't need to do till you get home, is get me the URL to that Google Hangout. Just email it to me, and I'll post it with everybody else's. Awesome. Sound good?
Do you have a garbage can in here?
To the door, out the right. Out the door to the right.